Okay, so just increase the volume so it works. Oh, it all works. So I'm Rebecca Frankel. You can see my name on the computer, and this is my vivacious volumes project. For the first part of the project, the cross-section part, I received a prompt where the base of the solid was a square root, so that it ended up being one curved line and two lines intersected at a 90-degree angle with an equilateral triangles acting as the cross-section for my base. Visible. The model was made from cardboard. It has 10 equilateral triangles in the actual model. Here you can see it, but in my spreadsheet, so you'll see in a second, I've made the calculations as if there was cardboard in all the cracks. So there's actually theoretically 38 cardboard triangles, if some of them are just invisible. This is the graph of my base, which was what I used to form the bottom of this model. Forget see, very exciting. Okay. Okay, due to the size of the cardboard model that I made, the spreadsheet has the amount of equilateral triangles that should actually be there, which is 38 triangles in total. I calculated the volume of the spreadsheet, making columns for my x value, top function, bottom function, side length. Why is it doing that? And all the other relevant parts, such as the area of the equilateral triangle, the thickness, and the volume of the cross-section, as well as the sum total. So I started with the x value, which I got straight from the amount and the thickness and the total prompt. My x value is actually 1/9, but because the spreadsheet was not accepting that, it's actually 0.11 something. 1111. So keep that in mind. The top function is simply the x value times 1/2, which is because it's from an equilateral triangle, and that's all the way down. The bottom function is 0, it's always 0. The side length is the same as the top function for this particular equation, but we just kept it because, why not? The area of the equilateral triangle is the top function times top function times the square root of 3 over 2 altogether over 2, which is the equilateral triangle area equation simply plugged in and put all the way down. The thickness is always the same because they're all cut from the same piece of cardboard. The thickness is 0.1111, also supposed to be 1/9, but same issue over on that column. And the final volume of the cross sections was simply the area times the thickness, with the sum total of everything being 2.43463751, even though that is a bit too specific for anybody's needs. Good try. Moving on to the integral part of this. This is, you can't see that at all. Okay. Is the brightness low? No. No. Okay, I'll just tell you what it is. So I started by keeping track of my basic equations for this entire scenario, which is y equals the square root of x y equals 0 and x equals 4. Then I changed that into the starting integral, which was an equation that I don't really wish to. Anyway, which was the 4 and 0 is the boundaries, and then the square root of x times square root of x times square root of 3 over 2 all over 2 dx, which simplified several times until it was the square root of 3 times x over 4 dx. Then we took the integral of that, which meant it turned into the square root of 3x squared over 8. Did the next part, the 0, you don't have to use that one, and when you plugged in 4, you got 2 times square root of 3, which is the end of this integral, and pretty close to the answer you got when you used the spreadsheets, though slightly bigger. And that's about as far as I have right now. There will be more at a later date.